Alright, next we are going to continue solving, but this time you notice we have more than one term on a side. Before we had a single term equals a single term. Now we got two terms, hence the plus equals one term. Alright, and our goal again, which will always be the same, is we have to get rid of the denominators. Alright, because first of all, I don't like working with fractions. So whenever I can, I like to get rid of the fractions by rewriting it. Or another time is, since I have a variable in the denominator, I can't solve this right now. So I have to rewrite this without any variables in the denominators. So what we need to do is we need to find the common denominator. You notice two of them have an x, so the common denominator looks like will be 5x. So both these have x's, but this one has a 5. So therefore I must combine the two, 5x. Now remember, it's an equation, so whatever I do to one term, I gotta do to every single term on both sides of the equation. So that means I gotta multiply this by 5x, this by 5x, and this term by 5x. Alright, so let me rewrite it out. So I got 5x times 15 over x plus 5x times 4/5 equals 7 over x times 5x. Now these are all assumed to be over 1. Alright, and it goes right back to the previous playlist on simplifying rational expressions. Alright, so here the x's cancels out, so I have 15 times 5, which is 60. I'm sorry, it's not 60. Oh my gosh. 15 times 5 is not 60. Oh, I had that. That's 75. I'm sorry. Plus, all right, so here the, excuse me, the 5's cancel out, so I'm left with an x and a 4, so 4 times x is 4x equals, here the x's cancel out, and left with a 5, so 7 times 5 is 35. And you notice the variables are gone. Now this become a linear equation, which is nice. So I should only have one solution. All right, the x is already is already on one side, so now I got to subtract both sides by 75. So I have 4x equals 75 minus 35 gives me a whopping 40, or negative 40. All right, and now divide both sides by 4, so x is equal to negative 10. Now I noticed in my original equation I had variables in the denominator, so I have to check this solution. So when I put negative 10 in for x here, will this be a 0? No, it's a negative 10. And the same thing here. So therefore, neither of these go to 0 in the denominator, so that is my solution. So that means I have no extraneous solutions at this time. All right? Let's look at one more example. Hopefully the next video we'll find some that will have extraneous solutions. All right? And that way you know exactly what I'm talking about. But I want to keep bringing this up, so that way eventually when I do cover it, you know, you've been hearing the term for a little bit now. All right, looking at the denominator, this is assumed to be over 1. So 2x and 1. So 1 times 2 times x is 2x. So multiply everything by 2x. Right, so I got 2x times 7/2 plus 2x times 3 over x equals 3 times 2x. So these are my common denominator. You notice I multiply by every single term. Right here, the 2's cancel out, so I got 7 times x is 7x. Here the x's cancel out, so 3 times 2 is 6. And here, nothing cancels out, so I just go ahead and multiply that 6x. Right, so this is linear, so I gotta get the variables on the same side. So I'll subtract 6x. And subtract negative 6. Alright, then go back, plug it into the denominator here, and that's not 0, so therefore this works, and in this case there's no extraneous solutions. So I just did, so in this video was just doing the same thing, except that I introduced more terms into the equation.